All right, good afternoon. I'm Eric Ward, Vice President for Public Programs at the Linda Hall Library. Thank you for joining us today for How Do I Become an Engineer, presented in partnership with the University of Missouri, Kansas City School of Computing and Engineering. Designed for students, How Do I Become is a monthly series held on the fourth Friday of each month. The program features scientists and engineers from a variety of fields. For more information about future How Do I Become programs and our many other public events, visit our website at lindahall.org. And if you have questions today, type them in the Q&A chat box you'll see at the bottom of your screen, and we'll get to as many of them as we can during the Q&A session. If you're watching on Facebook, just type your questions in the comments section, and we'll see them there. Now, to introduce today's speakers is Marjorie Eisenmann, Assistant Dean of Student Affairs at the Umkc School of Computing and Engineering.
Thanks, Eric. We're so glad to be co-hosting this event with you all today and excited to welcome all of the students and other guests who are interested in hearing more about how to become an engineer. We're excited today. We have our first speaker is John Buzzin. John recently joined aerospace manufacturer and suborbital spaceflight services company Blue Origin as an aerospace engineer specializing in parachute systems. Before that, he served as a design engineer for airborne systems, where he worked with a team on the NASA Mars rover. John completed his Master of Science in Mechanical Engineering at UMKC in 2016 after he completed his Bachelor's in Mechanical Engineering at UMKC in 2015. John grew up in Kansas City and graduated from Rutgers High School. And we're excited to welcome John to our program today. Thank you.
Thanks, Marjorie. I appreciate it. I'm happy to be here. I'm happy to talk to you guys, answer some questions you might have. I think first thing I wanted to do was show you guys a little video of some of the stuff that we do here at Blue Origin. Well, the video I'm going to show is an in-flight escape test. So I work on a rocket program called New Shepard, where it's a commercial rocket where we eventually will have paying customers to go up into space for kind of a 30-minute ride into space. And this test I'm going to show you guys is in-flight escape. So during ascent into space, if there were to be any type of problem with the rocket itself, the crew capsule, where you guys would be, gets ejected from the rocket and then lands safely on the ground. I specifically work on the parachute side of things. So let's get the video going.
Good morning, everyone, and welcome to the live stream of today's Blue Origin test flight.
So everything seems nominal for an exhilarating test flight.
Today's mission is totally focused on a successful crew capsule escape with the understanding that the booster will likely be lost. It's time to hand this show over to Mission Control so we can listen in on the final countdown.
I'm super excited to see this thing go.
Godspeed, New Shepard.
5, 4, command start, 2, 1. And liftoff. New Shepard has cleared the tower.
This is in our West Texas launch site facility.
New Shepard, live from West Texas.
Coming up here around 45 seconds is when we'll see our escape.
There it is, 70,000 pounds of thrust pushing that crew capsule.
And the B-3 engine remains on. The booster continues to space.
The drogues are out on the crew capsule. There go the mains.
Okay, so those 3 mains are reefed right now to keep them small. The reefing will remove shortly to fully expand, as you can see.
And touchdown of the New Shepard crew capsule. From what we can tell, that was a nominal in-flight test of our escape system. And again, all astronauts on board would have had a pretty exhilarating ride, but a safe ride.
The BE-3 will restart, and we'll wait for that smooth, gentle descent onto the pad. There she goes. Look at that. Nice and stable. Landing gear deploying. There you go. The booster's landing on tail of fire. It's got set and short. Beautiful.
Wow. There it is.
Touchdown.
What an extraordinary test and a tremendous final flight for both craft. If you're interested in learning more and keeping up to date on our progress, be sure and sign up on our website for email updates. And until our next exciting launch, Gradatum Ferociter.
So that was again our in-flight escape test. So just to give you guys a little bit of background on me, I'm from Kansas City native. And then I went to Rockhurst High School, graduated in 2010. And I really didn't know what I wanted to do. I think when I was in high school, at one point I wanted to be a fighter pilot, like throughout high school. And you know, it wasn't until my senior year of high school where I really was like, I think I kind of want to do something in engineering. But I was really into cars. I loved, you know, working on my own car. I was a bit of a gearhead. And so I thought like, hey, maybe I'll go design cars. Maybe that's kind of the engineering that I'll lean towards. So I also didn't have the best grades in high school either, just because I wasn't really motivated, because I didn't know what I wanted to do. And it wasn't until I got into college where I started kind of experimenting within the field of engineering and started to kind of find my niche and realize where my interests like really lied. And I will say, you know, not having the best grades in high school made college a lot harder. So once I figured out like where my passion was, everything was just a lot harder to do because I didn't have that strong background in high school. I was still able to do it. All it takes is discipline. You know, when I was in college, again, I was more focused on maybe going into the field of automotive engineering. So I kind of set myself up for that. I was part of the Umkc Baja team where we take a dune buggy and race it around the country. But then, you know, one day I was walking into class and I saw some people throwing parachutes off of the parking garage. And so I went to the professor that I saw was working with them, because he ended up being one of my instrumentation professors. And I said, hey, what were you guys doing? I didn't have an internship for the summer. Can I work for you? It wasn't particularly well paying. I don't know if it even paid at all at first. But it looked fun, and I was, you know, I wanted to do it. So I said, okay, I'll work for you this summer and see how things go. And I was like, wow, you know, throwing parachutes off the roof is pretty fun. And then gathering data, like really learning the science behind parachutes. But at the same time, I was still setting myself up to go into automotive as well, because again, I didn't really know. And then once it came time for graduation, I started doing job interviews. It took me over 6 months after I graduated to find a job. But then, you know, I ended up getting 2 offers at the same time, one from Detroit, one from Ford in Detroit. And I was like, okay, so I can go to Detroit and work on Ford F-150 chassis, like, you know, work on cars, work on trucks, you know, really get into the engineering behind cars. Or there was this small parachute manufacturer in Southern California that said, hey, come out here and design big space parachutes. So I went with my gut and I went to California. And the first project that I started working on was the Mars 2020 Rover parachute. And about 6 months into the job, I got to go to the largest wind tunnel in the world, about 180 feet by 80 feet. And we got to see, I got to walk around the tunnel and see this 100-foot, the actual Mars 2020 parachute inflated in front of me. It was the most spectacular thing I'd ever seen in my life. And it was that moment where I was like, okay, I made the right decision. I I really love being in aerospace. I get to work on my car on my own time. But from there, it was, you know, just about bettering my career. I just kind of did the right thing every day, and worked hard, and eventually had the opportunity to come up to Seattle and work for Blue Origin, where you really kind of take a step back, where I'm, you know, sure, I know a lot about the parachute side of things, but once I, you know, got to Blue Origin, I realized and started working on the parachutes within the entire system itself. So I really got to take a step back and work on the big picture stuff, which has been really fun. But the advice I have for you guys as high school students is to just keep working hard, and just try to find the discipline to get your work done, because I know that it sucks and you don't want to do it, and it's hard, especially in this environment where everything's virtual. But as long as you have the discipline and know, hey, in the future, I want to better myself, right? And I want to be successful. Even if you don't necessarily know like what that's going to look like, as long as you have that discipline right now in doing what you know you're supposed to be doing, things will fall together, just like they kind of did for me. I didn't expect to be here in Seattle after moving to California for 3 years. And now I'm working with rockets and space parachutes, and honestly, it's a blast. I'm having a ton of fun watching those rockets lift off and the parachutes like operate and the capsule landing, getting to work with, you know, some of the smartest people in the world. It's intimidating, but you know, I did the work and I know that I deserve to be here, and it's been a lot of fun. So that's kind of all I've got for right now. I don't know if there are questions in the chat. I haven't been able to. There's one question. I can start answering questions, or Marjorie, you can kind of take over.
Sure. Well, the question was asked, and it was from Joshua, age 9. Have you ever designed a space rover?
No, I've not designed an actual space rover itself. However, in college in Umkc, we did play around with small space rovers, and we had to design them and do all the instrumentation for them. So just go into engineering at Umkc and you'll get to get a little intro into it, into what that takes. I have worked on and designed the parachute to land the next Mars space rover.
That's great. I'm sure we'll have more questions later on, but I have a question for you. You know, you talked about that you weren't really sure of what you wanted to do.
I wasn't sure until, even when I left college, until I got my first job, I didn't really even know.
But you said, engineering curriculum in college is hard. There's no question about it. And you talked about just that you had to kind of focus and decide that this was what you wanted to do. What were what would you say were some of the biggest challenges, and knowing now what you know then, knowing now if you knew now what you knew then, or whatever, something like that. What would you tell your younger self about to be successful as an engineering student?
So the biggest thing that I think I've learned in industry and going from a couple of jobs is that when you're working in industry, engineering school prepares you really well to have the capability to adapt to whatever job situation you could see in the field. It's not necessarily like, hey, I'm in Calculus 3 and I'm doing the nitty gritty hard work and it really sucks. I haven't used Calculus 3 one time, but what I'm saying is having that background and being able to do that really hard math work gives me the ability to adapt to whatever situation that's going to involve some heavy math, maybe in the engineering, like in industry, in the field. So what I'll say is don't get discouraged. Again, for me, the golden rule is discipline. It's, putting in the time and the effort. I remember when I was in college, at one point, probably the most grueling point was where I, was working on my thesis, and I would go to school and I would be a TA and I would go to class and I would come home and I would eat, and then I would go back into the lab and write for like a few hours every day. But I only had to do that for a few weeks. It's those short little stints of the discipline and the hard work that'll get you through. But don't, you know, I'm a bit of a procrastinator, so it's not necessarily an example I want to set, but you know, it worked. And I'm not sure if that completely answers your question, but I think the big thing was knowing that once you get into industry, the work that you've done in engineering school just gives you the ability and the confidence to be able to succeed with whatever problem is going to come your way. Not necessarily that you're going to use all of that class knowledge and those specific, you know, things that you learned in college, but it gives you, it tests your ability to be able to adapt to the new situation.
Definitely. I think one of the other things that you mentioned is that how broad, specifically for you, mechanical engineering, but how broad engineering can be. It doesn't have to be very specific. So you don't have to know exactly what you want to do when you start an engineering degree, and it gives you a lot of opportunities. You had an opportunity to go into the automotive industry, and you had an opportunity to go into more on the aerospace side with your broad mechanical engineering degree.
Exactly. And that's a really good point. That's something that I should touch on, is that right now I'm an aerospace engineer. That's my job title. I didn't go to school for aerospace engineering. I went to school for mechanical engineering, and I did that. I went into school for mechanical engineering purposely because I knew that mechanical engineering gives you a very broad, you know, depth spectrum of different jobs that you can go into, because it's a very broad field. As opposed to, you know, going to a school that has an aerospace engineering program, you know, I'm doing the job. I know how to do it very well of aerospace engineering, but I have a mechanical engineering degree. I think that that's one of the things that UMKC does well in the mechanical engineering field, because they don't have an aerospace engineering, you know, background per se. But if you go into mechanical engineering at UMKC, you're going to learn some things about aerospace engineering, just like I did.
Thank you for that. Very good sell, because that's exactly how we've approached things at UMKC. And it's the same in our electrical and computer engineering program, and the same in our civil engineering program, that we want to give students as many broad opportunities, because then you get to focus in at your company, or opportunities to focus in on a master's degree, either at UMKC or elsewhere. So I think that's great. We're going to definitely come back to you after we do a little bit of talking. What we want to do right now is, one of the most exciting things that's happened at UMKC this year is that we are opening our new building, the Robert W. Plaster Free Enterprise and Research Center. And due to the pandemic, it's been a little bit slower getting the building finished and getting the equipment in there, but we are very excited about that. And we look forward to welcoming people to our building when it is safe to do so, and show you around. But we're really excited today to give you a little bit of an idea of what is involved, what is inside that new building. And this is definitely related to what John's experience was at UMKC, because he did research with Dr. Travis Fields in the drone lab. And this is the new lab, which we're really excited to show you the space and as it's going to grow. So we're going to show a quick video, and then I'm going to introduce one of our faculty to talk a little bit about these new spaces.
Welcome. We are now in the Unmanned Systems Laboratory here in the Plaster Center, where in the next couple of weeks or months, we're going to have this lab filled with students at the undergraduate and graduate level performing all different types of activities having to do with unmanned systems. And that could be ground, air, and underwater vehicles. And as a good example of that, right behind me, we have this unmanned aircraft. This is our largest system we currently have in our fleet, where we might be developing different aspects of this aircraft to improve its performance, its range, its capability, or even to add things like a payload carrying system, so we could deploy parachutes from this to get supplies on the ground. And you could think things like Amazon. So we have students that are going to come in here, and they'll be working on maybe the autopilot aspects of this, maybe trying to increase the strength of the structure so it can handle a larger payload, and so on. This is the kind of environment where you might see students working on all different pieces of this. So it'll be a pretty exciting laboratory. We're really hyped up to be able to get students in here and start building our aircraft, and again in this new Plaster Center.
We're here in the Simulated Aircraft Flight Laboratory at Umkc in the Plaster Center, and we have Professor Fields flying the aircraft, which is in a 3-axis system that allows the unit to pitch up, to roll, and to yaw to reflect the motions of the aircraft. And we use this unit in order to provide for our students in flight test engineering and aircraft design the opportunity to feel what it's like to fly an aircraft, and especially one that's configured in a way that's challenging to fly. We also use this as a research platform, so we can get pilots in and evaluate how they handle different tasks, especially ones that really exercise their ability to fly the aircraft. And the other thing is, of course, we use this for recruiting as an attractive way to advertise the Plaster Center. So this is Travis Fields flying what would be normally dangerous, but now we can do these things safely in a simulated environment, flying in downtown Kansas City after taking off from the downtown airport. And the great thing about this system is it's highly configurable. It's flexible for different aircraft types, for different flight dynamics models, and for different situations in which would be too dangerous to test in flight, but is definitely okay for the simulation. So right now, Dr. Fields has simulated an engine out and is testing how he responds to emergency situations. So here he is approaching the downtown airport, has his landing gear down, his flaps deployed, there's the propeller comes to a complete stop, and he's trying to figure out how to get back to landing safely. And this is not just a pilot training tool, but it's also an engineering tool that allows the engineering students to experience what it's like to fly the vehicles that they might ultimately design. When we purchased the simulator, we specifically purchased the MCX, which has 2 control systems, 2 control yokes, one left for the pilot and one right for the co-pilot.
So it is my pleasure to introduce one of the faculty who was in there with you in that video, and to tell you a little bit more about the space that we have in our new Plaster Center is Dr. Mujahid Abdul Rahim. He is an assistant professor at UMKC in the Civil Mechanical Engineering Department in the School of Computing and Engineering. He teaches courses on aircraft design, flight testing, and control systems. Mujahid has active research efforts in autonomous formation flying, pilot proficiency modeling, and aircraft drone collision safety testing. Mujahid earned his PhD from the University of Florida in 2007, then worked as a flight control engineer at AeroVironment, Inc. and SoftWorks for 12 years before joining UMKC in 2019. And we're excited to have him here to tell you a little bit more about our labs and the kind of interesting things that are going on there.
Thanks, Marjorie. So I'm going to follow John's lead very briefly and say, like, what started me out on this whole path. And John had the observation of working with Travis Fields. In my case, I was very young and I was on an Air Canada flight. And back then, kids were allowed to go visit the cockpit. And so the flight attendant asked me, would you like to go see the captain? Would I ever? So I went up there and I asked the question that every kid asks, which is, sir, how do airplanes fly? And so he took out a notepad and he drew for me the lift and the airfoil and the air on top. And he explained to me how lift was generated, and it actually inspired my whole life. But years later, I found out that his explanation was factually incorrect. So I feel a little bit scammed, but still, it's a great field to be in. And I'm happy to be here. But I finished my PhD at the University of Florida, and my focus there was essentially morphing micro air vehicles, which are small aircraft that can change the shape of their wings. And my experience there was really just, it's like you're in a hobby shop. You're welcome to build whatever you want. And that's sort of the same thing that we're bringing here. As John experienced when he went through this program, there's all sorts of opportunities to build, fly, test, iterate, and understand what the engineering process is like in order to develop these technologies. I come from a background of industry, so I didn't come straight from my PhD to teach at the University of Missouri, Kansas City. I spent 12 years at different companies. One of them was AeroVironment, which is every time you see a picture of a soldier holding an airplane, launching it on the battlefield, that's usually an AeroVironment aircraft. And so it was nice to come into a large corporation like that, which really tries to look at new and innovative technology. And how do you design, for instance, a vehicle that can fly for 7 days at 60,000 feet while running on hydrogen? And how do you design a tiny vehicle that looks like a hummingbird, for instance? So lots of great engineering challenges. And because I come from both an industry and academic background, I bring to UMKC a lot of that perspective. And so one of the latest contracts that we're on, and I'm very excited about this, is it's called the Field Reconfigurable Aircraft. And this is one that's going to exercise a lot of the laboratories that are in this new building. This is one where, typically as a customer would buy an aircraft, they get an aircraft delivered to them, and it's largely a fixed airplane. And if they want to do something different with it, then sort of tough luck, it can't do much different than what it was designed for. And we're proposing to the Air Force customer that we should build them a field reconfigurable aircraft, give them an airplane that is like Lego pieces. You can put the aircraft together, and whether it's a commercial, a scientific, or a defense endeavor, they can put together the aircraft that exactly meets their mission needs. It'll automatically reconfigure itself, figure what it needs to do, and then perform that mission. So that's one of the very exciting things that we have. Lots of the work that goes into that is taking place at the that drone space that we discussed. How do you get aircraft to being safely testing them in order to be able to look at things like rendezvous, autonomous vehicles that can fly in formation together, or a vehicle that can land by itself, recharge, and then take off. And we're doing a lot of that testing here in the building. What's behind me and what you saw on the video is our new flight simulator. And don't get me wrong, we're extremely excited about this and all the different things that we can do with it. But we named this laboratory the SAFE Lab, the Simulated Aircraft Flight Environments Laboratory. And the reason we use that acronym SAFE is because we're specifically targeting how to effectively mitigate against some of the dangers of flight. So for instance, one of the things that we're looking for is identifying pilot saturation or pilot task saturation. If you're doing a math problem and someone asks you to juggle and then chew gum at the same time and then also tap your foot, eventually you're going to be so overwhelmed by the commands, you're not able to do what needs to be done. And that's unfortunately what happens to a lot of pilots, especially if the weather gets bad and they can't see very well and it's complicated air traffic and they're screaming commands at them. That's where pilots get into a lot of trouble. And so we're specifically using the simulator in order to try to detect automatically when that happens. So when pilots are overwhelmed by the air traffic talking to them and the weather gets worse and the fuel is low and the system goes bad, all these different things together are stressors that make the piloting task difficult. So we want to be able to detect that automatically and hopefully swoop in with an automatic system and help warn the pilot, hey, something bad is happening. And if the pilot's incapacitated, help take over and land that aircraft safely for the pilot. So we have a variety of studies that we're doing, and obviously studies like these are better done in simulation where you can exercise a lot of these variations in flight without really putting anyone at risk. But you're developing systems that ultimately will help save lives, even if we're doing this on a simulated environment first. So another one of the initiatives that we have, I have a piece of an aircraft next to me. And so this is the wingtip off of a Cessna Citation. And we have pieces of aircraft here because in addition to looking at the safety in the cockpit, we want to look at the safety out of the cockpit. So you have these two things. You have drones, which are easy to fly and plentiful, and then you have real aircraft, which carry human beings. Now, what happens when those two meet together in an unfortunate way? Like what happens when an aircraft is flying and someone has this drone up and then the drone hits the wing? So we have a whole laboratory that's specifically designed to study that. And again, the new building provides us the opportunity to run these types of tests and these systems. So, you know, the story of Captain Sully Sullenberger, right, is classic, where he was taking off from New York, hit a bunch of birds, both engines flamed out, and he was down in the Hudson. That's a very, very fortunate event. He was able to save a lot of lives with his quick thinking. And what we want to do is help automate some of these things as much as possible. Birds and drones are different. One is very dense and built out of things like metal, the other's flesh and bones. But what happens, it's a good question, what happens if a 737 or even Cessna 172 hits a large drone? What happens to the wing? What happens to the structure, the aerodynamics, and the ability of the pilot to exercise control over that aircraft? So what we've done is we're building a very large drone launcher that takes stuff a drone in there and it launches it out at 200 miles an hour. And we have things like this piece of wingtip from a Cessna Citation. We have wings, fuselages, tails, flaps, landing gear, all sorts of things that we're going to hit as a way of cataloging the effect of impacts on different parts of the aircraft so that we can help with things like certification of the drone. What are the things that we need to do to design drones so that they're safer to hit they're safer to crash into, like crumple zones for a car, for instance. Maybe it helps guide policy on where we need to fly drones and where we shouldn't fly drones. And the other thing is helping automate the recovery. If something bad happens, God forbid, there's an impact with a drone and an aircraft, what do you do in order to help get those people safely down on the ground? So Marjorie, it's a quick summary of some of the things that we have. Do you have any questions?
I do.
Perfect.
If you could talk a little bit about the motion capture lab. In the video, we saw you flying a drone in the different hoops, but can you talk about some of the things you're going to use that lab for in your research, but what other faculty at UMKC can use that space for, and why it's such a great, it's so exciting for us to have?
So that's a great question. And one of the things that's important is Marjorie said it's the motion capture lab. It's not the drone arena. It's not the drone lab. The whole point is this is a laboratory which has a huge interior volume and has specialized cameras that can automatically detect the motion of things that are within. And it can be people, so how they animate movies and cartoons, right? They put markers on elbows and so on, and so they can get the motion of people. They can detect structures, ground robots, aircraft. So we have a variety of faculty working different types of research projects. One of them is looking at biomechanics and walking and how to, maybe it's prosthetics in order to be able to develop prosthetics that help people recover from injuries and get back to normal walking. Our work tends to center on vehicles, but not just air vehicles, also ground as well, and the interactions between those air and ground vehicles. And the last thing that I'll mention for the motion capture lab is because it can detect human forms and it can detect vehicles, we've been talking with the customer that works with the Navy to look at human interaction with drones. So instead of having a remote control and making stick inputs to command the drone, what about natural gesture interaction? So if you do this, for instance, let the drone fly away, command it to come closer to you, and we can use this space to very accurately replicate or to measure the motion of a human and subsequently have that command the vehicle and have the natural interaction between the man and machine.
That's great. Before, as we were talking before the event started, John was remembering having to put a net all over our main building, Flersheim Hall, to be able to fly the drones. And we're really excited about having this 2-story space to do that. And like you said, doing so many other things inside of there. Thank you so much for talking about the exciting new spaces that you are doing research in and some of the information. I really appreciate it. We're going to bring John back here and Eric coming back too. And we've got lots of really good questions from students, and we want to get those questions. The one thing I want to mention before we go into this is just how we've talked a lot today about aerospace. That's, where John's area is, and that's where your area is, but that mechanical engineering is an incredibly broad field, as well as other areas of engineering. And so we just we're really excited about the new spaces for you all, and we wanted to share that, but also, just letting students know that there's so many opportunities. And I think that some of the questions are really going to let us delve into that, because engineering is not, and I think you guys would both feel this way, it's not just one thing. You don't just do one thing only. You have to have skills in a lot of different areas. And so I think that's probably one of the things that I'm going to come away with most from this, is how you got to be able to do math. You got to be able to understand computers and programming. And you don't have to be an expert in any of those things, but when you have all that, that's what makes an engineer, is knowledge about a lot of different areas. So I'm going to turn it over to Eric to do some of the Q&A.
Well, let me add on to that, Marjorie. I'll direct this question to John. You talked about the various area, engineering, computer science. John, before we began today, you were also talking about the interview process. You had a Blue Origin, and you had to give a presentation, or multiple presentations, it sounded like. So it sounds like there are a lot of soft skills that you also need to be a successful engineer. How did you go about acquiring those, or what advice do you have for kids to require the public speaking and writing skills?
That's a great question. My short answer is practice interviews. I think early on out of college, I interviewed with Honda Motors, to work on their like sports cars. And I was not good at interviewing at that time. I think it was like my first interview out of college. And I really wanted that job. If I would have gotten that job, I would have taken that job in a heartbeat. And it was the interview that killed it, because I could have done that job. I feel confident that I would have been good at it, but I just wasn't familiar with the whole interview process, kind of what the things that you want to portray and get away with. I think UMKC has some great interview practice. You can do mock interviews, stuff like that. Really, I would really encourage you to take advantage of those before you get into any type of professional interview. On the flip side of that is, you just want to be able to communicate effectively, right? I think Einstein said that if you can't explain something to someone that like they're 6 years old, then you don't know it well enough. So it was something along those lines.
That's a good way to put it. Yeah.
But that's huge to me, and it all goes along with communication, right? So it's practice those skills as much as you can, and turn on your cameras when you're in school. Turn on your cameras, talk to the teacher, talk to the students in this environment. That's what I would recommend to practice and help in terms of improving your communication skills.
I would also add, it's been maybe a year and a half ago, I was talking to an engineer at Honeywell, and he's been in the field for a very long time. And he said to me, I should have paid more attention in English class. I actually spend most of my day writing, whether it's emails or reports. And because he's advanced in his career, but he said that is an area that he wished he had paid attention to. And I know a lot of engineering students aren't super interested in those English classes and the writing that they need to do, but it's some of the best preparation that you will have as a student, is learning those things, because you will, as an engineer, you don't just live in a vacuum where you only do engineering tools. You only do engineering things. You will write, and even getting into that, it's hard because it's not how we normally do things, but even writing emails, now as a student, writing them appropriately, writing them correctly with proper English and without, spelling out the word Y-O-U instead of just putting the letter U, and practicing those kinds of things will make it get into your mind. I will tell you, and Dr. Abdul Rahim can say this if he has had differing experiences, but I hear a lot of teachers and faculty say, I can't believe that this is how they addressed me in an email. And so, the faculty should be being written to in a different way. So just something to consider, not to blow off those classes, and to really pay attention, because the writing is important.
I would actually like to double down on that real quick, though, because when I was at UMKC, I did a bit of technical writing. I didn't take a class in technical writing, but with the research that I was doing, I did a lot of technical writing. I think I've got 4 publications from the AIAA, and that skill set has helped me so much in my career, both in California at Airborne Systems and here at Blue Origin. It is extremely undervalued, I think. It was by me. I'm guilty of it. I didn't hold a lot of value in writing and technical writing, but once I developed that skill set, it has made things so much easier for me in my career.
Marjorie, can I mention something quickly? On this note, my sister is a reporter, and she sometimes tells me, you should have been a writer. And my response to her is I am a writer. Like, that's what I do. And so when I get money for my research programs, I do so by writing my ideas onto paper and communicating them effectively with the government, who then decides, well, this guy clearly knows what he's doing, hopefully, right? And then can grant me money for it. The way the scientific community works, if you think of the body of knowledge, we're not all cavemen huddling over telling stories, right? We write things in a way that documents our experiences and our observations, and we share that in the body of knowledge. So we absolutely are writers. You know, we happen to write technically about the things that we do. And so it's very important. And Marjorie, yes, I'm gonna agree with you. Do not call a professor bro. I mean, as much as we're friendly, we are not bros, right? So there's a lot of appropriate ways to show that you, and we're not very formal, but you can show that you are respectful in an environment, and you say like, hey, professor, whatever it is, I'd like to know more about this. And we understand our whole job is to help inspire people and help take people through the early inspiration to professional careers like where John is right now. That's our job, and we're not old stooges or anything that are looking to to gatekeep. Instead, we're looking to help this process. And so by you being engaging and forthcoming, I think it works great.
Right. It's not all fun and games. Go ahead, Eric.
Oh, no, I was just going to remind people, if you have a question, you'll see a Q&A chat box at the bottom of your screen. Type them in there, and we'll get to as many as we can today. And if you're on Facebook, type your question in the comment section. Oh, go ahead, John.
Well, I was just going to say that, like, right now I'm writing some contractual documents. I would not have gotten this job if I didn't have a strong technical writing skill set. Maybe my previous job I would have gotten, but not the next step up, right? So it's just such a valuable skill set that I want to emphasize this. I can start jumping in on some of these questions. That's okay.
Sure. And well, let me get to this one. There was one on Facebook, and then, yeah, if you want to jump in on those. So a viewer on Facebook asked a question: what should they look for within an engineering program? And I know we have some out of town viewers, and I know Joshua, who asked a question earlier, is from Australia. So they can certainly attend UMKC, but is there some general accreditation standards that people should look for?
Yeah, the number one thing that students should be looking for in an engineering program is that they are ABET accredited. ABET is our accrediting body that accredits mostly schools in the United States, but it does accredit schools all over the world. And that's the number one thing to look for when you're looking at a school, because ABET accreditation, number one, make sure that the standard of your education is high, and that you will be learning the things that you need to do to be an engineer. The second piece of that is if you want to become a licensed professional engineer, which some engineers do, some do not. It really depends on the type of engineer you are and the field that you go into, if you want to do that or not. But in order to do that, you do need to graduate from an ABET accredited program. You know, John, I don't know if you did a lot of college searching or if you just knew UMKC or, you know.
Oh, no, that's it, ABET. That's it. The state of Missouri had 4 ABET accredited engineering schools. And it was process elimination. I didn't want to live in the middle of nowhere in Rolla. Wash U was too expensive, Ivy League. And Mizzou, I've never had a good experience in Columbia. So it was Kansas City.
But we love all those schools.
Yeah. Oh, yeah. Great. No, they're all amazing. But that was just my personal process of elimination.
And let me comment briefly on how to pick an engineering school. Obviously, ABET is the most important consideration, and that filters down into things like laboratories and whatever. But I would say, if you can, visit the school before you go there. Visit the school, check it out. It's important to match your interests with the school's capabilities, because there will be laboratories, and some of them have focuses that are different than others. And depending on what type of engineer you want to be, make sure that the school caters to that. And if you want to be aerospace or nuclear science, or you want to be mechanical or material science, find a school that has a strong background in that, whose faculty also have worked in that field and are publishing in that field. And that means that those faculty that are doing this expert level research are also teaching you, the student, how to develop those same skill sets. And that's really important if you can do your homework and find that type of information.
The other thing I would say is that you also want to look for the kind of support systems that are available at the university. So things, you know, we mentioned early on, engineering is a challenging course load. When we admit students to UMKC, we admit them because we believe they can be successful in it. And so I think that's a really key thing to know about about the engineering school, but also does the engineering school or the university that it's at, do they provide services like tutoring, things called supplemental instruction? Are there organizations for you to get involved in that will help you to both network and also make you feel, connect you to other students? And, I think those are the important things to do, because you need to know that there is going to be a support for you to be successful in the program. And, you also need to look for the fit. And I think most students, when you visit, get that experience. We know it's really hard right now because a lot of schools are unfortunately having to limit the in-person visits. We are hoping in the next few weeks to be able to put up a virtual lab tour of some of our labs at UMKC, so you can get an idea of what's going on in the labs until we can bring visitors back. And I know a lot of other universities are having that challenge right now, but I think that's probably the biggest challenge that we're facing, is that we can't really bring you physically to campus at this time, but hopefully soon you'll be able to visit our campus and other campuses to check them out.
Right, we have some questions about the simulator. One just disappeared.
I'm sorry, Eric. I just typed an answer to that, but
okay.
I can speak to it. So it was a great question, which was, can you set specific weather in the simulator? And I'll emphasize the reason we bought this is because it's so configurable. And the answer that I typed, if you want to look it up, is, yeah, we can set weather like wind, turbulence, rain, snow, visibility, clouds. But not only that, it's like an editor where you can say at 1,000 feet, I want this type of cloud and these winds. 2,000 feet, 3,000 feet, every different layer, you do different clouds. So as you're climbing and descending, you're experiencing different things. And I'll just be honest, right? We talked about my relationship with Dr. Fields. We have, we're here for doing science and for teaching. But when he's flying, I can use my phone to set the weather. So all of a sudden I can put him in the worst possible weather. Like, John, you know what I'm saying, right? So
I was just going to ask if you could randomize it. Yeah.
You can randomize it, and he'll be flying along doing an approach, and I'll fail the left engine, and then I'll fail the instruments. So in fact, it's not only the weather. So I say this jokingly, but really from a research standpoint, this is exactly what we're doing. We have these repetitive controlled failures that we can induce in the system. We have very specific weather conditions that we can do. So when we subject pilots to different situations, we're very, very controlled on what we're able to do. And of course, it's always safe. At a moment's notice, they can press pause, everything stops, and they can get out if they feel uncomfortable.
That sort of answers another question on here. Is it possible to crash in the simulator?
Yeah, and Travis is a lot better at crashing than I am. Am I allowed to say that? But yeah, the answer is yes, you can crash in the simulator. The simulator is not designed to basically have shedding wings and broken parts. So basically, as soon as you hit the ground, the simulation stops. Other simulations tend to show damage to the aircraft, but this is actually an FAA rated simulation, which is called an Advanced Aviation Technical Training Device. And so you can actually log hours. I can use this to get half my license that counts towards actually flying real airplanes. So this is not designed for the crashing, it's certainly designed for the flying, but it certainly simulates that.
All right, we have a question from a high school freshman asking about what kind of classes and activities should they do to get into engineering school at UMKC?
The number one recommendation I have to you about, especially as a freshman, is take as much math as you can and the hardest math possible. So if your school if you are on track and you can take calculus your senior year, take calculus your senior year. Take the hardest that you can. I know a lot of schools will offer a lower level, just a math before you go to college. Take it every year, take as much as you can, take the hardest classes you can. That will prepare you for engineering more than anything. Even if you don't get, some schools have dual high school credit, some schools have other things. You don't have to get that, but getting the experience in that will be the most valuable for you. The other piece that I would recommend is if your school has Project Lead the Way, take Project Lead the Way classes. If they don't, they have robotics teams or they have other types of physics or science clubs. Get involved in those because those will give you some hands-on experiences. You may not love it, but it'll help you determine what it is that you do enjoy. And so any types of activities you can get involved in. if the pandemic is better in the summer, we may be able to offer this summer. We may be able to offer some summer camps for high school students. So keep that in mind and look for other summer camps that are engineering focused throughout, whether it's at UMKC or other places as well. So just take advantage of as many opportunities. Project Lead the Way is one of the best opportunities to get involved in.
We have a question on Facebook about internships. Are there classes that need to be completed before trying to get an internship? And I guess the big question today is, during the pandemic, how does one go about getting an internship?
There's lots of opportunities for internships, and I will tell you that, I don't know every single student in the School of Computing and Engineering at UMKC, but I only heard of one student whose internship was canceled due to the pandemic. Most companies still had student interns, so that's a great thing to keep in mind. I will tell you that most companies do want to see a little bit of experience. A freshman college student doesn't usually have the experience that they're looking for, but it's not unusual it's not impossible to get an internship. And this is where networking comes in. A lot of times people don't want to utilize the connections that they've made or the people that they know, but especially when you don't have a lot of experience, utilizing networks is the best way to find an internship. At UMKC, about 80% of our students do complete at least one internship by the time they graduate. And usually we'll do that the summer after their junior year of college. One of the things that we do find is that many of our students, because there are so many opportunities in Kansas City, that many of our students will stay on for their internship during their senior year of college, working 15 hours a week at their internship while they're finishing up school. And then the other thing is that a lot of those students also get those full-time or those internships turn into full-time jobs. And so they never actually do a job search. And I don't have the results from graduation in May, but from the year before, 92% of the students who walked across the stage at graduation in the School of Computing and Engineering had a job lined up, or they knew they were in an admission to graduate school. So the job market is incredible. There are jobs for engineers, and both in Kansas City, and then John had the experience of going out to Southern California. So there are lots of opportunities. And fortunately, we have not seen a huge cut in those opportunities because of the pandemic.
Yeah, that's great news. That sort of answers another question someone posed about after getting your degree, where should you start applying for a job? And part of the answer to that is don't wait until you get your degree, right? Yes. Start the job search prior. John, how early were you? How early did you start looking for a job?
Constantly, always, constantly and always. Like you were saying, Marjorie, utilizing those networks, connections, talk to people, go to conferences. That was huge for me. Conferences. That was how I ended up in California. This is a good story. So in between my junior and senior year at UMKC, I was one of the few that didn't find an internship. I had done small internships before, in between my sophomore and junior year, but I wasn't able to secure one in between my junior and senior year. So what I did instead was do research in the lab at UMKC, where I would have been working with Dr. Abdul Rahim. It was that research that led to me going to a conference and there meeting contacts to then later get a job in California. So.
Yeah, research is one thing that you can do sometimes earlier. I know that working in your lab, you have Dr. Abdul Rahim, you have a student who started actually the summer before he started at UMKC. And so it is possible. It's not everyone, starts that early, but there is opportunities for undergraduate students to do research. And that's a big.
And I just announced in my class that I'm looking to pay people money to do research with me. Sometimes it's volunteer. Sometimes it's like, take my money because I need help here. But John, I want to give you the perspective from the industry side, where I was a recruiter for my company, going to college campuses, trying to recruit people. Because just like students sit and say, I would love to be hired by companies, companies say, I would love to get good students. And companies are always on the hunt for good people. So this is matchmaking. And so you pointed out that you went to conferences and you made some good contacts there. That's how I was hired. I got a job offer before I finished my PhD because we go back to this technical writing and communication. My professor forced me to get on an airplane and go to Colorado and give a talk. And right afterwards, the guy gave me his business card and said, I want you to work for me. And I did. And that happens a surprising amount. So that's part of why I think it's so important to get engaged in the process. But I don't want to take too long, but I want to say one more thing. In the process of recruiting for my company, I had people give me resumes, and what it said on it is degree in aerospace engineering, and that's it. And conversely, you have people that say, first robotics, team captain, degree in aerospace engineering, I was in the drone club and the rocket club and the whatever it is. And you don't have to do all these things necessarily. But the question that came up earlier is, what do I have to do in high school to get accepted into a good college? Marjorie, I love your answer, right? Is, concentrate on math, certainly, and do a lot of the things that make you attractive as an applicant. Because if you can come in with a little bit of robotics experience, whether first robotics or Mindstorms or something, and you have a good foundation in math, you're automatically an attractive student that, we're going to pull from this end. You don't have to push. We're going to pull because we want you in our laboratory.
So one of the questions is, what does a student do if if their school doesn't have any of those extracurricular activities? Maybe you could answer that.
Yeah, that's a good point. And sorry, Marjorie, go for it.
Well, here's the awesome thing. There is so much online. There is incredible amounts of, all you have to do is type STEM or STEAM activities into Google and you will be inundated. Here in Kansas City, we have the KC STEM Alliance. I would encourage you to go to their website. They have tons of resources. I just got an email today and about all the things that are going on. There are a lot of opportunities that exist out there that are not associated necessarily with a high school. So, and you may be, especially now, as we have been dealing with the pandemic, a lot of things have moved virtual and giving you a lot more opportunities. This event today would have been in person if there wasn't a global pandemic, which would have been too bad because we wouldn't have gotten to hear from John because he lives in Seattle. And, we wouldn't have gotten to have some of you join us today because you may not be in Kansas City. So a lot of us are realizing that virtual has a lot of benefits to be able to share the great information that we have.
So one of the things I'll add to that is, what can you do? So John, that's a great question. My school doesn't have a first robotics team. What do I do? Some of the people that I most wanted to hire were people that had the initiative to do projects on their own. So one young lady said, I built a solar powered car in the backyard with my dad. I'm like, I want you right now on my project team because that sounds fantastic. And there's a lot of things like that. And so you can look at Arduino, which is these little tiny $10 boards in which you can program to do different things. That's a small investment. You can do that, learn it. If you do things like you want to be in robotics, well, buy a tiny robot kit, program it to do different things, and then by all means speak of it. Yeah, we're doing fancy autonomous drones, but a student coming to me saying, yeah, I'm pretty familiar with Arduino is one that I want to work in my lab. So lots of self-initiated projects that don't have to rely on sort of high school infrastructure for you to be an attractive candidate.
Right, we're approaching the top of the hour, so let's do a couple more questions. We have a couple questions about computer science. One is how much computer science is used with the drones, and another person asked, as a student taking engineering classes, should I also take some computer science classes or work on certain coding languages?
I'm really interested to hear the answer to this. I want to know what languages do you all use the most in your work?
So John, I'll let you answer afterwards, but my quick answer is yes, absolutely. Because we're not building World War II aircraft where everything is bolts and rivets, right? We're building systems, which means computers and everything. So everyone likes to design wings and wheels and engines, but really there's a computer system on board that has to figure out where it needs to go and what it needs to do. So if you can do C, C++, Python, Java, and honestly, it doesn't even matter which language you learn, but be proficient in programming and computer science. Often, if you look at the recs for companies, so when they're doing a requisition, they have a new job opening. Yeah, they want a couple mechanicals and electricals and all the other stuff, but sometimes they're all desperate for computer science guys and software engineers that are really capable of understanding how everything comes together. They write the program that reads the sensors and drives the motor and displays to the pilot what that pilot needs to see. So there is no way to understate how important it is to have a background in programming, no matter what type of engineer you want to be.
Yeah, I just want to echo that. I've worked, I've kind of dabbled in all of them. C, C++, MATLAB, Python. I think Python's huge right now. It's really growing. If you can, you know, and it's free. So if you want to mess around with it, download it, you know, just go online, look for some tutorials, just get some familiarity with it. I feel like that's going to be a strong one. I personally use MATLAB the most, but it's not really a coding language per se, but more MATLAB's kind of an engineering tool for data analysis, more so. But that's what I use the most. If I knew Python or C++, I think I would be using it a lot more. That's the thing. If you know it, you're going to be using it in engineering, because there's always going to be areas or people that want things done in those languages.
All right, we'll end with this one. John, what was the hardest part about working on the Mars rover? Any white knuckle moments there? I
do want to say I worked on the Perseverance rover, not the Curiosity rover. The Curiosity rover landed when I was in high school still, but on the Perseverance rover, what I want to say, just kind of like an overarching challenge, I think, was the material science involved, because NASA's very, very strict and particular about what they send to space, and especially to Mars, because we don't. So one of the things that we have to do is we have to actually bake everything. We have to cook everything that we send to Mars, so we can kill every possible type of microbial life that might be on it. And so you need to have a really good understanding of all of the materials that are on your system to know how they will behave in, you know, a 4-day oven. And if they're going to be, you know, react any certain way. You know, it's in general, the whole issue with, you know, microbial life and how they interact with materials was that was quite a challenge with working on, you know, stuff going to Mars.
It sounds like fascinating work. I'm looking forward to watching future Blue Origin launches as well. And
yeah, thank you.
Someday taking a ride into orbit, hopefully. So.
No, sign up. I think, you know, I don't know when we're going to start flying people next year. So
I think the price point will need to come down probably than what it will be set. But thank you, John, for joining us today.
Thanks for having me.
Thank you, Professor Abdul Rahim. I need to get over and check out the new building. I know I've been saying that to Marjorie, that I drive by it about every day, and
Simulator is always open for you, sir.
All right. All right. And thank you, Marjorie, and UMKC School of Computing and Engineering for co-presenting this with us. I love these programs, and I look forward to more collaborations.
Absolutely. And thank you so much for having us join you for this. I also want to mention several questions have been asking about getting into UMKC and what it takes and learning more about us. And we're so excited to hear that. I'm going to put a URL in the chat, but also you'll see on your screen a website and a QR code. If you want more information, we would love to tell you more. We're hopeful that we're going to be able to, that things will be in good shape, that we'll be able to share, bring some students to campus in the spring semester and let you take a look around our new playground of our building. So we're excited, but please give us your information, reach out to us. We have lots of ways to connect with students.
Yep, now's your chance, scan that code. And you also see in the, as Marjorie mentioned in the chat box, a link to the Umkc website. So thank you all again, and thank you everyone for tuning in today, and we hope to see you back here soon at a future program. So thank you, and have a great rest of your day and a great weekend.
Thanks, everyone.